Hello, good morning, class, or good afternoon, whatever the case may be. We're going to do one last test on single values, and so let's look at this. First of all, if you had any questions on the homework, you can check the homework answers online. I'll be happy to answer them when I come back next week. So I'm going to get right into the lesson, okay? So what we're looking at here is paired data. Okay, it's paired data, which really means we have two different samples, but we're looking at the difference in the samples to really make it look like we have one sample. So comparative studies are more convincing than single sample investigations for that reason. One sample inference is less common than comparative inferences. Study designs that involve making two observations on the same individual or one observation on each of two similar individuals results in paired data, and we use a method called paired T procedures. It's paired, but on the calculator it's going to still be a T test. So let's look at the problem. Is the express lane faster? So for the second semester project in AP Statistics, Libby and Catherine decided to investigate which line was faster in the supermarket, the express lane or the regular lane. So to collect their data, they randomly selected 15 times during a week, went to the store, bought the same items. One of them would use the express lane and the other would use the regular lane. To decide which lane each would use, they flipped a coin. If it's heads, Libby used the express lane and Catherine used the regular lane. If it was tails, the opposite happened. They entered their randomly assigned lanes at the same time, and each recorded the time in seconds it took them to complete the transaction. So we're to carry out a test to see if there's convincing evidence that the express lane is faster. So first, here's our data. Notice we have two sets of data, the time that took in the express lane and time in the regular lanes. Notice data 1, this means that Libby or someone was at the express lane, took 3:37, while at the same time her friend took 3:42. So even though it looks like two samples, we're really just interested in the difference, which in this case was -6. So we're going to have to find the differences of all these to get our one sample that we're going to test. So I suggest using the calculator. So here's what you do. Put the express lane in list 1 data, the regular lane in list 2 data, and then in list 3, you're going to say at the heading, you go up to the heading and say, I want list 3 to be L1 minus L2, and it will find all the differences for you without you having to calculate them out. Plus, it's in our calculator to do any other operations. So all the data isn't listed here on this screen. You'll have to refer back to the other screen to get the data. Once we have the data in the calculator, we can do one var stats to see the mean, and in this case, X bar was -42.67, which means on average the express lane was faster, but was it significantly faster for us to believe there's a difference? And the standard deviation of our sample was 84.02 basically. So that's the information we need from there. Now we're going to do the state, plan, do, conclude. So essentially we start out with our hypothesis. We make mu of D is the difference in time. It's really express minus regular. It's that third column that we calculated. So we're going to take the null hypothesis that mu of the difference is 0, meaning there is no difference in the time for each lane. We want to see if there's evidence that the alternative is right, where mu of D is less than 0, which would mean the express lane time is faster. We should check conditions, and if conditions are met, we're going to do a one-sample t-test for difference in means, which I think on your calculator is just called a t-test. Random, well, the problem says that we randomly selected the times. The 10% rule, well, we're going to assume there's at least 150 times they could do it in the population. And normal, well, the sample size is less than 30. So we're going to have to graph it. So I've provided two graphs. We could do it on our calculator. There's the box plot or the histogram. And looking at either one, there doesn't appear to be any real heavy skewness or outliers. So we're going to call that condition met. So next we're going to have to do the do part. We need the test statistic and the p-value. So looking at using our calculator to do this, we go to the t-test, and we have the data in our calculator. So we're going to choose data there for that. Mu of 0 or mu naught is really our null hypothesis, which we're assuming that mu is 0, that there's no difference. Our data is in list 3, L3, so make sure that's in L3. Frequency is 1, and the alternative down here is that it's less than, that the difference is less than 0. So as we continue, we look and do our t-test, and we find out that the test statistic t is 1.97, giving us a p-value from that screen of 0.035. If you did calculate and run the test, those are the numbers that we get. And usually our significance level is 5%, so we can see that in this case p is small. So therefore our conclusion, since our p-value is small, we reject the null hypothesis. That means we do have convincing evidence that the time in the express lane is faster. So anyway, there's our example, and you can kind of follow that. It's just like a one-sample test, which we've done before. So I'll let you get started on the homework exercises, which they're listed here in the video. I'll run through them slowly if you want to use the video to look at them. You'll just have to hit the pause button as you do them. But anyway, good luck on that. We'll review this next week before the test. So we'll talk to you later. Enjoy. Just scrolling through all the problems for you. Hope you have a nice weekend, and Cassidy says hello.